Hi, today we are going to start about the first session regarding the PySpark. So first we need to understand what is Spark and all, then how to write the Spark or how to use the Spark framework by using different programming language. So before getting to PySpark, let's try to understand what is big data. Let's talk about what is big data and all. Then we'll see what are the problem exist in the traditional ecosystem like big data and Hadoop. Then we there is a requirement to use the Spark or PySpark, and we jump into PySpark. Okay. Now coming to big data, please observe the data measurement table. So measurement start with bit, byte, kilobyte, and megabyte. Like whenever we want to measure something, let's say you can measure the liquid substances, maybe liter, milliliter, okay, and all. If you want to measure, let's say vegetable or let's say any fruits item, then you can use like kilogram, okay, half kilo, 1 kg, 2 kg, 10 kg, and all. Okay. Similarly, to measure the data, we use different type of measurement parameter that is called bit, byte, kilobyte, megabyte, gigabyte, and all. If you are discussing about the terabyte, petabyte, and exabyte, etc., then your discussion is related to big data, and that data is called as big data. Big data can be structured, semi-structured, and unstructured. Basically, the data is divided into three different categories. Either it may be structured data, or maybe semi-structured data, or unstructured data. Now let's see the table which will give a clear-cut idea how the volume of the data increases, and in addition to that, respectively, we increase different parameter to measure it. For example, if I use only bit, then the value will be either 0 or 1. Okay, size is 1 by 8 of byte. Whenever I am telling byte, 1 byte is nothing but 8 bit. That is 1 byte, you can see. Now coming to kilobyte is nothing but 1000 byte. Similarly, megabyte is nothing but 1000 into 1000 byte. Similarly, keep on increasing like gigabyte, terabyte, petabyte, exabyte, zettabyte, and yottabyte. So till kilobyte, megabyte is fine. But whenever you are talking about, let's say, terabyte, petabyte, exabyte, zettabyte, and yottabyte, that comes under big data and all. To handle such type of data, traditional tables are not enough. Like Oracle, MySQL, SQL Server, PostgreSQL, and DB2. Okay, for that we have to rely on HDFS file system, Hadoop distributed file system to handle big data or to store the big data. Okay. Now, fact. So today, every company is holding and generating big data regularly. Now, one question arises in our mind. Whenever we are telling big data, how much data, how big it is? So generally, it's too much of data. For example, let me show you a funny diagram. By seeing that, you'll be able to understand how much data we call it as big data. Anyhow, measurement wise, we got to know if the data volume is more than, let's say, terabyte, petabyte, exabyte, zettabyte, and yottabyte, that comes under big data. Now, in the diagram, let's try to understand. You can see there's a horse. Horse carry different, goods. If I will just load more number of goods, if the volume of the goods is too high, then you can see that this maybe the situation may arise. Okay, that comes under too much of data or big data, which a horse is unable to carry. Okay, challenges with big data. So when it comes to big data, we need to take care of about two challenges. Okay, one is if we don't know how to face those challenges, then it turns to problem. Okay, so one is how to store the data. There are two different challenges, major challenges: how to store the big data. Second one is how to process the big data, huge amount of data. So to resolve such type of problem, to resolve these challenges, Hadoop provides a beautiful platform to store the data that is called HDFS, Hadoop Distributed File System, and to process the data, it provides one of the beautiful processing engine that is called MapReduce. In short, we call it as MR. MR stands for MapReduce. Okay. Now, small real story. Once upon a time, years back, you can see in 2006, only two companies know how to store and process the big data. In 2010, Almost 300 companies know how to store and process big data. But in 2019, almost 1,000 companies know how to store and process the big data. You can see in 2006, only Google and Yahoo, those two companies know how to store. Okay, but slowly, as the technology evolved, lot of company moved towards using big data Hadoop ecosystem. Nowadays, they are completely rely on cloud-based data storage also. You can see 2000, even Google and Yahoo face problem like how to store and process the big data. Even though they are using, still there are two challenges where they are in front of those giant company. Okay. Now in 2000, both companies made separate development center to solve big data problem. 2002, around 2002 and 2004, Google company found solution and research, released GFS, Google File System, and MapReduce paper. Duck cutting, working in Yahoo, understand the GFS and MapReduce, implemented one software and released as open source to world. Thanks, duck cutting and all. Okay, now alert. We started discussing like imagine, right? So now imagination is done. Request, please wake up. Those who are in the sleep mode, please wake up and all. Okay, now we can see, as I told you, think about Hadoop is a kind of coin. As coin having two different faces, like head and tail. Similarly, the head part, the side A is called storage part. Side B is for processing part, that is called tail part. You getting my point? Now, Hadoop, we can use Hadoop, as I told you, mean for two different purposes. For storage layer, for processing part. In Hadoop 1.x onwards, Hadoop 1.0 version onwards, we have something called HDFS, Hadoop Distributed File System for storage layer, and MapReduce is used for processing part. But Hadoop 2.0 onwards, we have something called HDFS plus YARN. Again, for storage layer, it will rely on HDFS, Hadoop Distributed File System. But for processing part, there is another, a powerful component released at Hadoop 2.0 onwards, that is called YARN. Yet another resource negotiator. You can see the full form is written here. Hadoop, HDFS, Hadoop Distributed File System, and YARN, yet another resource negotiator. Resource allocation plus processing part. Both the things it will take care. Even if the job scheduling part also it will take care. Okay. All big data companies start following Hadoop. You can see nowadays almost all the big companies are following Hadoop and all. No advantages. By using Hadoop, we can store and process big data. HDFS is the best storage file system to store big data. But coming to processing, Hadoop have few limitations. I'm sorry for saying when it comes to Hadoop processing area, that is MapReduce, but Hadoop itself having few limitations. While processing big data, more read and write disk operation are required in Hadoop, so processing is very slow. Now what are the advantages? By using Hadoop, we can store and process big data. HDFS is the best storage file system to store big data as of now. But coming to processing part, MapReduce is not that much efficient part. Hadoop has few limitations. Okay, I'm sorry to say when it comes to Hadoop processing area, that is MapReduce, Hadoop itself having few limitations. While processing big data, more read and write operation are required in Hadoop, so processing is very slow. You can see. Then how to overcome that? The issue or the problem that we faced in Hadoop, that is in the terms of MapReduce for processing part, we overcome by using the Spark. So there is another scientist called Mathai Jairia. The name is Mathai Jairia, who is the creator of the Spark. This fellow, you can see. Okay, he is the person who has created the Spark. It's a beautiful processing engine. Mathai Jairia worked with Hadoop team. He designed and implemented the core scheduling algorithm which are used in Apache Hadoop while doing his PhD studies. Basically, he created the Apache Spark. Okay, guys, this is just an introduction. Going forward, we'll go in depth and try to understand what are the different modules present in Spark, how Spark is working as a unified platform to work with batch data processing, streaming data processing, MLIP machine learning library, GraphX. Then if I want to use any R programming language also, there is a separate module called Spark R. I can use and I can integrate R programming language, I can work. Spark streaming module, Spark core module, Spark SQL module, each and everything will discuss one by one in depth. Thank you so much. Have a nice day.